In this video, we're going to be looking at trigonometry. Now, trig from tri or triangle essentially is a way of finding the lengths or angles in right-angled triangles. So just like Pythagoras was able to find the lengths within right-angled triangles, this is sort of an upgrade and allows us to find the angles in these right-angled triangles. Now, there are two types of question. One here on the left where we know the angle, and the one on the right where we don't know the angle. And I'm going to show you how to do both of them. Luckily, the process is pretty similar for both. Now, the first stage we need to do is label our triangle. So in this first triangle here, the first thing to look for is where is the angle that we're looking at. Now, in this case, we know the angle, but even if we didn't, it doesn't matter. And then we label the sides based on that angle. So the 30 degrees here, we look to the opposite side here, and this gives us the opposite side there. Okay, so and once we've got our opposite side, we can then use that to work out the rest. So this one here, this 6 here, would be the adjacent side. Adjacent is just a fancy way of saying next to, and then the longest side here is the hypotenuse. Some of my students call it the hippopotamus, the large side. Okay, the largest side. Now we can do the same thing with the questions where we don't know the angle. So in this case, this would be the opposite one, this would be the hypotenuse, and this would be our adjacent. Now, just a quick note, if the angle was here, okay, if the angle was here, then this one here would be the opposite side. But in this case, it isn't, because our angle is the one at the bottom there. Okay, so I'm just using that more as an illustration. It does matter a huge amount where your angle is. After labeling your sides, the next thing you do is you write so, ca, toa. Okay, there's a few different ways of remembering this. Silly old Harry can amuse himself tickling orange ants, or some old horses can always hear their owners approaching. Whichever way you remember it, there's you just write your so, ca, toa, and I'm going to do it again here. So, ca, toa. Now, the reason I'm doing two questions at the same time is just to illustrate that the process is the same for both of them, whether you know the angle or not. Now, the next thing we do is with this first one on the left, we know the angle. The side we want to know is our opposite side. So I put a question mark above the opposite, and then we tick the ones we know, which is the adjacent. Okay, and then I look for which one has a question mark and a tick, and in this case, it will be our toa. Now, what does toa actually stand for? Now, toa stands for the equation tan of the angle, tan x, is equal to our opposite divided by our adjacent. Okay, now, of course, that's the toa equation. What do the other two stand for? Well, the so stands for sine of the angle, or sin, the angle there, is opposite over hypotenuse. Okay, the ca here stands for cos of the angle, or cosine of the angle, is adjacent over the hypotenuse, and the toa stands for tan of the angle, is opposite over adjacent. So these three you need to remember, but the little SOHCAHTOA helps you remember those. Okay, so now we have our equation we're going to be using tan for this one on the left. But let's have a look at the one on the right. What are we going to be using? So instead of a question mark, because we don't need to know any of the sides, we tick the ones we know. Well, we know the adjacent here. Okay, so we know the adjacent, and we know the hypotenuse. And again, we look for the one that has the two ticks, and that's the ca, and that stands for cos of the angle will equal our adjacent over our hypotenuse. Okay, fine. Now let's do the one on the left. So what we've got here is tan of x is equal to opposite over the adjacent. So I rewrite the equation. Tan of 30 degrees, which is the angle, will equal our opposite, which we don't know, over our adjacent, which is 6. Now, in order to solve this, to find out how long the side is, it's pretty straightforward. All we then have to do is multiply both sides by 6, because we're just trying to get this x on its own. And so we get 6 times by tan 30 is equal to x. Now, how do we then do this? Well, I get my calculator out. and I type this into the calculator. So I do 6 times, and then I press the tan button, and 30. Now on many calculators, it's good practice to close the brackets that the tan puts in for you, and we press equals. Now we get this rather strange answer of 2 root 3 here, but all we have to do is press the SD button, and we will get x is equal to 3.464 ... So we can say that that's roughly 3.4623SF here. Okay, so that's our answer. So that tells us that our opposite side is about 3.46. Now, if this was centimetres, that would, of course, be centimetres there. But how do we do it when we don't know the angle? Well, we simply fill in the values. Cos of the angle, which we don't know, cos x, is adjacent, which is 5, over our hypotenuse, which is 8. Now, we just need to solve this. How do we do that? Well, currently, there is a cos in front of the x. Now, many people think what you try and do is divide by cos or something. The problem is cos is not actually a number. We need to do inverse cos. We need to do the opposite of cos. Now, let's have a look at these. So, what is the opposite of sine? Well, it is sine to the minus 1. Just like the opposite of multiplying is dividing, the opposite of adding is subtracting. The opposite of cos is cos to the minus 1, or inverse cos, and the opposite of tan is tan to the minus 1. Well, where do we find this? In fact, if you look on your calculator, there will be a sine button, and above it, there'll be a sine to the minus 1. Now, how we access that one here is we press shift to get that, okay? So, how do we do this with the question that we're looking at? Well, we currently have cos x is the same as 5 over 8. So what we do to get rid of this cos here, because we've just got the x on its own, we do the cos to the minus 1, but we do it to both sides. So what we're left with here is x is equal to cos to the minus 1 of 5 over 8. Now we can just simply put that into our calculator. So I press my shift cos, I press my fraction button, 5 over 8, and then I press sideways and press close brackets. And what I've got here is that x is equal to 51.31781 ... So x is equal to 51.3 degrees to 3 SF. There we go, and that's how we find the angle. So again, recap. What we have here is you label your triangle, and then you write SOHCAHTOA. You tick or question mark the sides that you want to know. You fill them into the relevant equation, depending on whether, in this case, we're using TOA, so we're using tan. In this one, we're using cos. And we fill them in, and then we solve both of them, and we get our relevant values. Now, sometimes you get questions that are a little bit harder. You find that they are embedded within a 3D shape. The process is fairly similar, but what you do is you separate them into actual triangles that you can see. So this question here says, find the angle that AG makes with the horizontal. So find the angle that AG makes with the horizontal. Now, AG is this red line moving across the image, but what we can do is draw another line to help us from B here to G. And what that does is it actually creates a triangle. Now, it's a 2D triangle within a 3D space, and it will actually be a right angle triangle here. So let me just sort of colour it in kind of green, but this triangle here. And what we're actually looking for in this question is this angle here. It is the angle that AG makes with the horizontal, i.e. the flat plane at the bottom. Now, the way I think about it is, imagine we're actually finding the angle, because it's very hard to know exactly where the angle, which angle we're finding. We're actually finding the angle that AG makes with its shadow if there was a light. So if we had a light shining directly from above, the shadow would actually go from B to G, and that's the way of thinking about it. I think that makes it a lot easier to sort of think about. But let me just show you the process, and then we can see how we go. So the first thing we need to do is we need to find the length of BG here. Okay, so BG. Now, that's quite straightforward. So what we're going to do is, if we're looking directly from above here, what we end up actually having is a rectangle. So if we actually look from above, okay, and say that this is our B, and this is our C, and this is our F, and this is our G. So I'm looking directly above. What I'm looking for is I'm going to get that blue line there. Okay, so I'm going from B to G. I'm finding that line BG. So what I do is this. We know that this length here is 6 and this length here is 4. So we can actually use Pythagoras to find this. Okay, so what we do is we go 4 squared plus 6 squared. So that's 4 squared plus 6 squared will give us the length BG squared. Okay, so 4 squared, of course, is 16. 6 squared is 36. So 16 plus 36 is 52. And we square root the 52, which, here we go, let me just square root 52. And I get the answer 2 root 13. Now, of course, you can press the SD button to get the value. But actually, since we're going to be using this value, we might as well just leave it as the 2 root 13. Okay, so we know this length here is 2 root 13. Again, you can press the SD button if you want to, but I'm just going to leave it as this, especially as we're going to use this value. It's easier to type than typing in all the decimals. Now, once I have the length of BG, what I can actually do is redraw this triangle ABG here. Okay, and again, redrawing I think is the key to doing these questions. That's our A, that's our B, and that's our G here. So this was the green triangle that was above here. Okay, now what we've got is we know the length of BG is 2 root 13. There we go. And we also know that the length AB is 3 here. And we're trying to find this angle. And that's the angle that AG makes with the horizontal. Okay, so what we then do is we label our sides. Okay, so we've got our opposite, because it's opposite this angle here. We have our hypotenuse, hypotenuse, and we've got our adjacent here. Then again, we write SOHCAHTOA. I'm going to tick the ones that we know. Well, we know our opposites, okay, and we know our adjacents, and we can see that we're going to be using TOA, and the TOA stands for tan of the angle is equal to our opposite over our adjacent. Okay, so tan of the angle, which we don't know, this is the one we're looking for, x, is equal to our opposite, which is 3, over our adjacent, which is 2 root 13. And I can just plug that into the calculator. So tan x is equal to 3 divided by 2 root 13, which gives us 3 root 13 over 26. And that looks pretty horrible, but all we then have to do to get the x on its own is we do the opposite of tanning, which is tan to the minus 1, or inverse tan. But remember, we have to do that to both sides. So we have tan to the minus 1 of this 3 root 13 over 26. And we just put that into the calculator. So I just press Shift tan to get the tan to the minus 1. And then I can press my answer button and then close the brackets. And the answer here is x is equal to 22.58853, which is 22.6 degrees to 3 SF, or whatever we're asked for within the question. So that is how to find this angle, the angle that AG makes with the horizontal. So just a quick recap: with any trigonometry, you simply label the sides. Okay, so we label the sides, then we write SOHCAHTOA. We tick off or question mark the sides that we need to know or know. That will give us which equation to use. Then we can substitute into the equation and solve it to get an answer. And again, it doesn't matter whether you know the angle or don't know the angle. I've done those side by side. And then sometimes the harder parts for these are being able to spot them within 3D shapes. Sometimes we might also get them within circle theorems. So if we have a circle here, pretty badly drawn, and if we have a line that goes through the center of the circle, that's a diameter. And if you have two lengths coming off that diameter here, this is known as angles, and this is circle theorems, angles in a semicircle, and this here will always be 90 degrees, meaning that if they ask you to find that angle there, or indeed the other angle, then you can use trigonometry to do that too. So again, it's mostly just being able to spot where this fairly straightforward rule is being used.